Okay, let's talk a little bit more about limits. And we write, the notation is this: limit x approaches a, f of x equals L. And we say the limit of f of x, limit of the function. So as x approaches, gets closer and closer to a, does not have to get to a, but it gets closer and closer to a, f of x, or the y value, f of x is y, approaches L. So what you know, okay, so what we do, let's try to get an idea of what's happening here. What we're going to do is try to guess the value of the limit in this example. We're going to do the limit of the square root of x minus 2 over x minus 4 as x approaches 4. Now notice, for this function, f of x, it's undefined at 4, so we can't get to 4, but we can get as close as we want to 4. So that's the idea of it. We want to know what's happening at 4 or around 4. So we have to use a limit. We have to approach 4 because it's never going to be equal to 4. Okay, so what we do is we're going to take some x values and we're going to get closer and closer to 4 here. And I'm going to use my calculator. So I'm going to find the value of these. Okay, so I'm going to use you can use the table feature. And I get the values. When I use my calculator, I get 2.583, 0.25403, 0.25016, 0.25016 here. So you need to try this on your calculator, and you can see that these values kind of approach 0.25. So I'm going to guess 0.25, which is 1/4. Okay, but here's the problem. When you're doing the graph and we're guessing these values, here's 4. We're coming in from the left. We're starting at 3.5. and getting closer and closer to 4. So we're approaching 4, but we're never going to get to 4 because it's undefined at 4. So we can't get to 4, but we can get as close as we want to 4. So we're coming in this way from the left of 4. We also have to come in from the right of 4. Okay, so let me draw this. Here's 4. We have to come in from the right, and the x is approaching that. And for that, we're going to use these values. Let's use 4.5, 4.25. See, I'm getting closer and closer to 4. 4.1, 4.01, 4.001. So I'm getting closer and closer to 4. I'm going to use my calculator to get this. You can use your table on your calculator. Okay, so here I'm going to get 0.24264. And then I'm going to get 0.24621. And then I get 0.24846. 0.24984, and finally 0.24998. And again, you can see that that's going to 0.25. So again, we're guessing that to be 1/4. Now what this means in a picture, okay, here's 4. So we're coming in here, we're coming in here. Our y values are going to 1/4. That means the graph is approaching 1/4. So here's 1/4 on the y value, and we're never going to get there, so I'm going to draw a dotted line. So as we come in from the left, y is coming into 1/4. Now we don't know if it's positive or negative, but we're going to, yes we do, because it's above 0.25, and here it's below 0.25. It's coming in this way, but on either side they're both approaching 1/4. Now how do I know it was coming in below? Because if you look at the table, all the values in the table right here, you're coming in below 1/4. Those are less than 1/4, and here you're coming in above 1/4 because those are greater than 1/4. So that's how you tell on the graph, and you can graph this on your calculator. But what this tells us is that the limit as x approaches 4, we're going to guess that it is. We haven't proved it yet, but we're going to say that the limit is 1/4. And again, this is just a guess. We'll learn how to prove these things later. All right, so it's important that you saw that we had to go from both sides of 4, the left and the right. So let me do some examples, some pictures here. Here's a curve of f of x, and here's a point on it, and this point is A, and we'll say this is L. So in this picture, if we're approaching A from the right, we use a little plus sign. This is approaching A from the right, f of x. Okay, so this curve is f of x. So let's see. As we're approaching A from the right, you're following the x-axis into A. This is asking us in English, where's the graph going? So as you're coming in, at the same time, you just use your finger, follow in the graph. The curve is going to the point L. So this is equal to L. X approaches A with a minus sign. You're approaching A from the left. Okay, so this time you're coming in A. You're on the x-axis. X is approaching A. Your y value, as you follow in the curve, is approaching L also. So we say that the limit as x approaches A from the right, and that's the same as the limit x approaches A from the left, then we know that the limit exists. It has to have a limit, the same limit on both sides, in order to have the limit as x approaches A. And we say that that's L. So the limit has to be the same from both sides. Okay, let's look at this example. Suppose we have something like this going on. Okay, here's A. Let's say this is L, and this is M, that point. So this is at M, and this is at L. So the curve jumps. When it reaches A, it doesn't ever exactly reach A, but you can get as close as you want to A, and then it jumps up to M for like a millisecond, and then it comes back down and travels on. So the graph goes like this, jumps up there for a minute, and then comes back down and continues on. Okay, so what's the limit as x approaches a from the right? Okay, you're coming in from a on the right on the x-axis, so you follow in the graph. Where's the graph going? Well, the graph, as x approaches a from the right, the graph is just getting closer and closer to this point that's not there. But that's okay. That's our answer. Our limit point does not have to be on the graph. And this is really important because it's where is the graph approaching? The graph is not approaching this point. It's only up at M for a little while. So the graph is approaching, if you follow the graph, it's approaching the open circle, which is L. That means it's never going to get there, but that's okay. That's why we have to use the word limit. It approaches it. It doesn't get there, but it approaches it. Let's do the same thing from the left. So as you're getting closer and closer to A from the left, at the same time, follow the graph. Where's the graph going? Again, the graph is coming into L. They're both approaching the same point. The limit point does not have to be on the graph. A limit is asking where is the graph going, or what point is the graph approaching. So we say here that the limit as x approaches A, f of x is equal to L, since these are equal. So in order for the limit to exist, the right-sided and left-sided limits must be the same. Okay, let's look at another example. Okay, here's the graph here, then it jumps up here. Okay, that's the open circle. It has to be, one of them has to be open or it won't be a function. You can't have two y values. Okay, so again, this is A. Let's let L be down here and M be up here. Those are the y values. So the limit as x approaches A from the right, okay, we're coming in, approaching A from the right. Well, the graph is coming and approaching M. Now the limit x approaches A from the left in this example. Okay, we're coming closer and closer, approaching A. Come down here to the graph. The graph is approaching this point, L. And since they're different, the limit as x approaches A, f of x, does not exist because M is not equal to L. They have to be the same in order for the limit to exist. Now you have a right-hand limit and you have a left-hand limit. Those exist, but we don't have the limit because they're not the same. And notice, M does not exist. The point M is the open circle. But we don't care because all we want to know is what the graph is approaching. Now, if the graph does something like this, oscillates, then there's also no limit as, well, let me get to that. That has to do with infinity, so I'll mention that later. Okay, let me look at another graph, one more graph. And finally, we have this one where A doesn't even exist. The point at A doesn't even exist. Okay, let me go back up here for a minute. Now, if I ask you the function values for these, like in this case, what's f of A? F of A, you'd have to say is M, because the point this point is a m. So this is asking you, what's the y value for a? Well, it's m, even though the limit's different. So in this example, f of a is what? Where's the point, is what it's asking us. Well, f of a, if you follow a, the point is right here at L. So this notation is asking you what the y value is for a. The limit is what is the y value approaching. So it could be different. Like here, in this case, f of a does not exist. There's no point. So when they ask you for f of a, they're asking you for the point. The limit is what it approaches. So limit as x approaches a from the right. We're coming in from a from the right. The graph is coming in to L even though it doesn't exist. And as you come in from the left, coming in from a from the left, the graph is still approaching L. So you have a limit here. The limit as x approaches a is L, but the point doesn't exist. It's an open circle. The point does not exist, and that's how you write that. So we have a limit, but we don't have a point. Okay, it's important that you know the difference between those two things. Those are called one-sided limits. So let's do some more examples. First one, I have this curve. This is 3, and this, say, is 4. So we have the limit as x approaches 2 from the right. That means we're coming in this way. So you have to follow this curve. We get 4. It's approaching the y value 4. Limit as x approaches 2 from the left. Coming in from the left, the curve is going to 3. So the limit as x approaches 2 does not exist because those are not the same. So it's important that you look at the right and the left. Okay, here's 2. Well, let's make it 3. And this is what the curve looks like. This is 1. This is 2. Limit x approaches 3 from the right. Okay, coming in from the right, the curve is approaching 2. Coming in from the left, okay, coming to 3 from the left, the curve is also approaching 2. So that tells me that the limit as x approaches 3, f of x is 2. Okay, but if we ask what is f of 3, this is the point. Where's the point? F of 3 is defined to be 1. So make sure you understand the difference between limit and a point. Here, let's go back here. F of 2, where's the point? F of 2, the point is at 3. It's not at 4. It's undefined at 4. The point is at 3. Okay, let's talk a little bit about infinity. Let's look at the curve y equal 1 over x. 1 over x looks like this. It has vertical and horizontal asymptotes at 0. That's 0. So I want the limit as x approaches 0 from the right. Now notice this is undefined at 0. We can never talk about this curve at 0. 0 is not in the domain. But we can approach 0, so we can ask ourselves what's going on as we come in from 0 from the right, follow the curve as we're coming in. So we're coming in closer and closer to 0. So where are the y values going? The y values going to positive infinity. Okay, this is a really important deal to remember. It's saying if you have 1 over a very small number, as you're coming into 0, you're getting to be like a half, a tenth, 1 over 100. So you have 1 over a very small number. It's going to approach a very large number. And that makes sense. Reciprocal of small is large. Let's try from the other side. Limit as x approaches 0 from the left of 1 over x. Okay, I'm coming into 0 from the left, getting closer and closer, so I have to come down here and follow the y values. Well, it looks like y, these are the x's, these are the y's. The y's, where's it going? It's going to negative infinity. So this is saying 1 over a very small negative number becomes a very large negative number. 1 over a very small positive number goes to the very large positive number. These are really, really important facts. So since they're not the same, limit of x approaches 0 does not exist or is undefined because they're different. But if you look at y equal 1 over x squared, which looks like this, if you take the limit as x approaches 0 from the right, okay, we're coming in from the right, the curve is going to positive infinity. The limit as x approaches 0 from the left, coming in from 0 from the left, so the y values, where are the y values going? As you follow the curve, as you follow the x-axis into 0, the y values are shooting out to positive infinity also. So here, since they're both the same, we can say the limit as x approaches 0, 1 over x squared, is positive infinity. Okay, well this tells us something. If we have the limit as x approaches a, f of x, equal a positive or a negative infinity, then we have a vertical asymptote at x equal a. Okay, so this concludes our limit discussion today.